All right, here's the video for Note 6-5, Graphing Quadratics. So in this lesson, we're going to learn how to graph quadratics by hand. We know we can use GeoGebra, or not GeoGebra, Desmos, but we should be able to graph this by hand using some of the characteristics and then plugging in some points to get some other points. So we need to use at least 5 points. So first, let's just identify the characteristics that we know. In terms of concavity, we'll look at the value of A. So this is going to be concave up. Our y-intercept, we look at the value of C, so that's going to be 0, 5. Our axis of symmetry, we can calculate. Remember, the formula is negative b over 2 times a. So b is 4, so negative 4 over 2, and a in this case is 1. So that becomes negative 4 over 2, which is negative 2. So my axis of symmetry is x equals negative 2. And then lastly, my vertex, well, I know my vertex is going to be negative 2 comma something. And then to get the y coordinate, we're going to plug in negative 2 for x. So negative 2 squared plus 4 times negative 2 plus 5. So negative 2 squared plus 4 times negative 2 plus 5. So the y value of my vertex is equal to 1. All right, so now let's just plot these points so we can get a general idea of what it looks like. So I'm going to plot my vertex first, so negative 2, 1. Okay, then I'm going to plot my axis of symmetry. So we know the axis of symmetry cuts the parabola in half. And I'm going to go ahead and plot my y-intercept, which is 0, 5. Okay. Well, if we know that this is our axis of symmetry, we're actually going to use as a line of reflection. So basically what that means is we know that we have symmetric points on a parabola. So if this point is 2 units away from the axis of symmetry, I know its symmetric point is going to be 2 units to the left. So what we're going to do to get another point is we're going to reflect this point over our AOS, and it's going to give us another point. So that coordinate is negative 4, 5. So symmetric points have the same y value, and then the x value is the same distance away from our axis of symmetry. Okay, so now we have 3 points. So now we just need one more point. And then we can reflect that over. So to get one more point, we just need to pick an x value somewhere around our axis of symmetry. Well, if our axis of symmetry is at x equals negative 2, let's just go over 1. We don't have a point on this value of x yet. So we're going to plug in a point. We know it's probably going to be somewhere between these two, but we're going to plug in the point x equals negative 1 and see what we get. And that's going to give us a point on this particular x value. Okay, so just like we did up here, we're going to plug in negative 1. So plugging in negative 1 for x, we get a value of 2. So another point on my parabola is going to be negative 1, 2, which looks about right. That's what we would expect given how parabolas look. And just like with the y-intercept, we can reflect over our axis of symmetry. So it's 1 unit away from my axis of symmetry, which means it's going to be 1 unit away. And that's going to give us our 5th point. So that's going to be negative 3, 2. So now I have my 5 points. I have my y-intercept, its symmetric point, my vertex, my other point, and its corresponding symmetric point. So now, last thing I should do actually is kind of connect these points to draw in my parabola as best as I can. There we go. All right, so let's look at another example, but this time it's given to us in factored form. Well, factored form, we know the concavity. We're looking at the value of A. It's negative, so we know it's concave down. Our x-intercepts, we look at inside of parentheses to see what value for x would make this 0. So that's going to be 6, 0 and 3, 0. Our axis of symmetry, we're going to calculate. And remember, it's just the midpoint of our x-intercept. So it's going to be 6 plus 3 divided by 2. So that's 9 over 2, which is 4.5. So x equals 4.5 is my axis to symmetry, which is going to give me half of my vertex. And then to get the other half of my vertex, I'm going to plug it in. So I'm going to plug in 4.5. So I have negative 4.5 minus 6, 4.5 minus 3. It gives me 2.25. All right, so now let's plot some of these points. So 4.5, 1, 2, 3, 4 and a half, and I'm going to go up 2 1/4. So 2 1/4 is maybe right here. Our axis of symmetry is going to be here. And that axis of symmetry is important because that's going to be our line of reflection. I'm going to plot my x-intercepts. So 6, 0, 1, 2, 3, 4, 5, 6, 6, 0, and 3, 0. All right, so we have 3 points. That just means we need to plug in one more point. Okay, so we're just going to plug in something around here. So I see I have a value at 3. So let's just plug in one more going over at 2. We're going to plug in the value of 2. And that's going to give us a point somewhere along here. So we know it's probably going to be somewhere down here. But let's actually plug it in. So negative 2 minus 6 and 2 minus 3. So just plugging in the value for x. So now our x value is 2. We get negative 4. So 1, 2, 1, 2, 3, 4. And that's where we would expect it to be, given our parabola is concave down. And then we can get our symmetric point. Well, this is 1, 2 1/2 away. So there's a half, 1, 2. So its symmetric point, when we reflect it over the axis of symmetry, is going to be 1, 2, 3, 4, 5, 6, 7, negative 4. And now I have my parabola. All right, last example in vertex form. So first of all, starting with the concavity, we'll look at the value of A. It's positive, so we know it's concave up. In this one, axis of symmetry, we don't actually have to calculate it because remember, axis of symmetry is just x equals whatever h is, and h is going to be positive 3. Remember, it's the opposite side. And then my vertex is going to be hk, so it's going to be 3, negative 5. Actually, let me do that in a different color. So this was up, x equals 3. And then my vertex I'll do in blue, 3, negative 5. All right, so 3, negative 5, 1, 2, 3, 4, 5. My axis of symmetry, which we're going to use as our line of reflection. Okay, well, in this problem, we're not given 2 other points. We're not given a y-intercept. We're not given x-intercept. So that means we're going to have to plug in 2 more points. Okay, so for our first point, again, we're just choosing points around our vertex. So I'm just going to go 1 to the left. So this is x equals 2. So I'm going to plug in 2 to our equation. So plugging in 2 for x to get our y value. So we have 2 minus 3 squared minus 5. Get negative 3. So let's plot that and make sure it looks right. 1, 2, 3. Yeah, that definitely looks right because we know our graph is concave up, but we can get our symmetric point. So we're going to reflect it. And its symmetric point is going to be right here, and the coordinates of that point is 4, negative 3. Okay, and then we're just going to need one more point. So let's just go one more to the left. So let's plug in x equals 1. So 2, 1 minus 3 squared minus 5. That's going to give us our y value. We get a value of 3. Again, let's make sure that that looks right. Should be somewhere up here. So 1, 1, 2, 3. That definitely seems right, considering our parabola is concave up. So let's reflect it over to get its symmetric point. So that's 2 away. So 2 away, the coordinates of that point is 5, 3. Now we have our parabola. Okay, so let's do a couple of the homework problems. So starting with this one, it says graph the function, use at least 5 points. So this one is in factored form. So I'm going to get the concavity, which we know is down because it's negative. We're going to get the x-intercepts. So it's going to be negative 1, 0 and 3, 0. We're going to calculate our axis of symmetry by adding our x-intercepts, negative 1 plus 3, and dividing by 2. So that's going to be 2 over 2, which is equal to 1. And then from there, we can get our vertex. It's going to be 1, comma, and we're going to plug it in. So negative 2, 1 plus 1, 1 minus 3. 8. Okay, so let's graph some of these points. So 1, 8 is right here. Our axis of symmetry is here. I'm going to plot my x-intercepts are at negative 1, 0 and 3, 0. Okay, and then we just need one more point. So the point that I'm going to plug in is going to be close to the axis of symmetry. So let's plug in 0. That seems like an easy one to plug in. It'll give us a point along this line right here. So we're going to plug in 0. So plugging that in for our x value to get our y value. Oops. So 0, 6, 1, 2, 3, 4, 5, 6, which seems right considering that we know our parabola is concave down. And from there, we can get its symmetric point by reflecting it over. That's going to be 2, 6. So now we have our graph. All right, now let's take a look at example number 5. So this one is in standard form. So again, we're going to start with the concavity. So it's going to be concave down. We can get our y-intercept, which is going to be 0, 1. We're going to calculate our axis of symmetry by doing negative b over 2a. So negative 4 over 2 times a. So this becomes 4 over negative 4. So we get an axis of symmetry of negative 1. And then we have our vertex. So it's going to be negative 1, comma, and then we're going to plug it in. So negative 2, negative 1 squared minus 4 times negative 1 plus 1. So we get a value of 3. So plotting my vertex, negative 1, 3. It's here, my axis of symmetry. We can plot our y-intercept, which is 0, 1. And we can reflect that point over. So its reflected point is going to be negative 2, 1. and then we need one more point. So my final point, again, we want to be somewhere around our axis of symmetry, because if we go too far, we're going to be off the graph. So we already have a point at 0, so let's just plug in 1 and see what we get. So plugging in 1, we have -2 times 1 squared minus 4 times 1 plus 1. So we're plugging in +1 now. We get -5. So 1, -5. 1, 2, 3, 4, 5. And then its symmetric point is going to be right here. So that's going to be -3, -5. So there we have our graph. All right, lastly, number 6. So this one is in vertex form. So concavity is concave up. Our axis of symmetry is going to be x equals +8. And then our vertex is just going to be 8, -7. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay, so there's our vertex axis of symmetry, which is going to be our line of reflection. So in this case, we're going to have to plug in 2 points. So starting with the first point, we're going to pick something close to our axis of symmetry. So I'm just going to plug in, if this is x equals 8, let's plug in 7. So it's going to be 7 minus 8 squared minus 7. -6. So 7, -6, 1, 2, 3, 4, 5, 6. And we can get its symmetric point right here, which is going to be, that's 8. It's going to be 9, -6. And then we need one more point. So let's just go, we plugged in 7, so now let's plug in 6. So 6 minus 8 squared minus 7. -3. So 6, -3 is here. Its symmetric point is going to be here, so that's 10, -3. And there's our parabola.